Alright, so today begins the graphing unit. Most of this will be review, but it's going to help lead into our continuity and end behavior section that we will do after this. Okay, so this is one of 3 videos. The first start is just basic graphing. Remember that in number 1, this is slope-intercept form. Okay, which is y equals mx plus b. So you start at the y-intercept, which is 0, and then you graph the slope, which is m. The y-intercept in this example is just 0. Remember that if you don't see a number there, it's implied that it's 0. Okay, and then since the slope is negative, it's going to fall to the right. So negative slope falls to the right, positive slope rises to the right. So it's rise over run. So we're going to go down 1 and to the right 2, or up 1 to the left 2. Okay, and you should use a straight edge when graphing lines. Obviously a lot straighter than that. That's the gist of how to graph a line in slope-intercept form. Okay. The next example is what's known as point-slope form, and the reason why it's called that is because you are given a point and the slope. Okay, so x1 and y1, there's your point, and then the number in front is the slope. Okay, the one thing you have to remember is that it's kind of like the opposite on the inside for the parentheses, so this ordered pair is actually negative 8, 1. So you start at negative 8, 1, and then the slope is 2, so you rise 2, run 1, going in the positive direction. Now people always ask, can't I just put point-slope form and slope-intercept form and graph from there? You can, but sometimes, actually in this example specifically, the y-intercept will be off the graph. So you actually have to start with the point that was given to you and then just graph the slope from there. Alright, the next example is for horizontal and vertical lines. Hopefully you've seen this at some point, hoi vux. So H is for horizontal, O is for 0 slope, and it's a y equals equation. V is for vertical, U is for undefined slope, and x equals equation. So in example 3, we have x equals 2. So that means it's going to be a vertical line, and we go to where x equals 2, and we just draw a vertical line. Once again, using a straight edge. Okay. Notice that anywhere we go on this line, x equals 2. Okay. Alright, next example. This is going to be the hoi. So you have a y equal equation with 0 slope. Okay, you don't see like 5x or 1/2 x. And this is going to be a horizontal line. So you plot a point. Okay, so you're going to plot a point at negative 2. And then since this is a horizontal line, you just draw on a horizontal line. And just like before, no matter where you go on this line, y equals negative 2. Okay. Alright, next example. This is known as standard form. This is where both the x and the y are on the same side. Okay. And you can go ahead and find the x and y intercept, but just going along to what most of you are probably going to do, and that's going to be to solve for y. So 4y equals negative 3x plus 12, and then divide everything by 4. So you get y to equal negative 3/4 x plus 3. And now we are in slope-intercept form. So start at 3. Our slope is negative 3/4, so we're going to fall to the right, so go down 3 and to the right 4, or you can go up 3 and to the left 4. Okay, please make sure you guys are using a straight edge. It's kind of hard to do on the iPad, but please make sure that on the quiz and the homework you guys are using a straight edge. Okay. All right, so that concludes the first part of our graphing section. The next thing we're going to get into is family of functions. All right, the first family we are going to take a look at is absolute value. You guys aren't going to have to know how to actually graph them. I mean, you should, but you're going to be more assessed on, can you write the equation for them, can you tell the transformations, and can you do the domain and range? Okay, so for absolute value, the general equation is y equals a times the absolute value of x minus h plus k. Okay, where hk is the vertex. Okay, so if you look at our graph, this point right here would be the vertex. Okay, and the parent function, so basically that means the function that everything is based off of is y equals the absolute value of x. Okay, and that's this example over here. That is the parent function. So anytime the vertex moves off this or it flips down, there's some type of transformation, which we'll talk more about tomorrow. Okay. The domain for a absolute function is always negative infinity to infinity. No matter what, there's nothing that we can't plug into an absolute value function. Okay. And then for the range, if a is greater than 0, meaning your graph is opening up, then it starts at the k value of the vertex and goes to positive infinity. And then if a is less than 0, then we come up from negative infinity. Sorry, that should be an open bracket. We come up from negative infinity and we go to k, and that's where we stop. And the biggest thing to remember for absolute value is you have a V graph for absolute value. Okay, so V for absolute value. The next graph we're going to look at is the quadratic. And that's very similar to the absolute value. It's just that it is now a parabola shape, which is the U shape. And instead of having the absolute value bars in the function, it's going to have being squared. So y equals a times x minus h squared plus k. Okay. And then the parent function is y equals x squared. And the domain, just like absolute value, is negative infinity to infinity. There's nothing we can't plug into a quadratic. And the range, if a is greater than 0, which means your graph is opening up, you start at k and go to positive infinity. And if a is less than 0, you come up from negative infinity and you stop at k. That means your graph is opening down. Okay, so this would be opening up, this would be opening down. So notice that a quadratic is very similar to an absolute value. It's just two different types of functions. Okay. All right, our next function is going to be the square root. Okay. And the square root general equation is y equals a times the square root of x minus h plus k on the outside of the square root. Okay. hk is your starting point. And the parent function is just y equals the square root of x. It's the basic square root. Okay, but we are going to have restrictions on the domain and range. Okay? If underneath the square root you see a positive x, so that means that x has a positive coefficient, then your domain is going to start at h and go to positive infinity. If you have a negative coefficient in front of x, so for example, the square root of 1 minus x, then you are going to start at negative infinity and go to h. Okay, and we'll do more of these examples tomorrow, but this is just for information. And then for the range, if a is greater than 0, you start at k and go to positive infinity. A is less than 0, you come up from negative infinity, you stop at k. So the example on the left would be an example of where you start at k and goes to positive infinity because we are going in the upwards direction. So that means a is positive. Okay. All right, we have two more functions to look at. Then we're going to talk about how to find x and y intercepts, and we'll be done for this video. Okay, so these are going to be the tougher of the two, or the two tougher ones of the graphs we've been doing. So the first is the general equation for an exponential function. So we are exponentially growing. So y equals a to the b, times b to the x plus c plus d. Okay. And the asymptote is y equals d. If we go over to this example right here, the asymptote is going to be y equals 0. And remember that an asymptote is a line your graph approaches but never touches. So we can't go past that line. So we're either going to be above it or below it. Okay. The domain for exponential is negative infinity to infinity. And then the range is based off of the asymptote. Okay. If a is positive, then it's an open bracket at d and goes to positive infinity. Key thing here being open bracket because you can never touch the asymptote. If a is less than 0, we come up from negative infinity and we stop at d once again with an open bracket because we can never touch. So touch the asymptote. So for exponential and logarithmic, your ranges are going to have all open brackets. For absolute, quadratic, and square root, you can actually include the endpoint. Okay. All right, so if we look at logarithmic, remember that logarithmic and exponential functions are just inverses of one another. So that means that it's flipped over the line y equals x. Okay. So the general equation would be y equals log base b of x. Okay. And in this example, the asymptote would be x equals 0. Okay. And how you find that is you take the inside of the log, and it can't equal 0. So inside of log can't equal 0. So in this example, I would take x and set it equal to 0, and that would be my asymptote. The domain, if it's a positive x, just like square roots, it starts at that number that made x 0 and goes to positive infinity. If it's a negative x, we come up from negative infinity and we stop at that number, once again being open brackets. And then the range is negative infinity to infinity. So notice that logarithmic and exponential switched. They flip-flopped. Okay, so domain for exponential is negative infinity to infinity. But then for logarithmic, the range is negative infinity to infinity. Okay, so just make sure that you guys keep this straight. If you ever forget, you can always plug numbers in, and if you get an error, then you know that maybe that function should be logarithmic because logs, the insides can't be negative or equal to 0. Alright, the last thing we're going to talk about is how do you find the x and y intercept graphically. So the x-intercept is where the graph crosses the x-axis. Okay. And then the y-intercept is just where the graph crosses the y-axis. So hopefully off a graph, that would be pretty straightforward. Okay. But then how do you find x and y intercept algebraically? So if you think about it, for the x-intercept, it's on the x-axis, and no matter where you go on the x-axis, the y value is always going to be 0. So you plug in 0 for y, and you solve for x. Okay? And you should always write your intercepts as points, so whatever the x value is, comma 0. And then for the y-intercept, the same thing. So no matter where you go on the y-axis, the x value is always going to be 0. So you're going to plug in 0 for x and then solve for y. So your point is going to be 0, comma y. Okay. And then lastly, how do you find it numerically? So this would be an example where you're given a table. So the x-intercept is going to be where y equals 0. So you just go on the table, wherever y equals 0, you know there's going to be an x-intercept. And then for the y-intercept, you go to the table, and it's where x equals 0. Okay. So that concludes our video for day 1. Tomorrow we're going to talk more about transformations and how to graph a little bit, like how to read information off graphs. And then the last day is going to be focused primarily on domain and range. Okay? Thank you for taking the time to listen, and your homework is worksheet 1. Have a good day.